writing a one-step expression for a real-world situation. All right, so real-world situation just means they're going to give us a word problem, meaning they're going to give us context or a background, a small story to go with the numbers that we've been dealing with. So a lot of students, again, stress out about word problems. Word problems just help you relate what it is you're learning in math to something real. Because a lot of the time, if we just see this equation, 270 plus b, we don't really relate it to anything in our life. But if we get a story behind it, it all of a sudden means something. So word problems just give you a background. They give you meaning. So last week, David drove 270 miles. This week, he drove b miles. Using b, write an expression for the total number of miles he drove in 2 weeks. So we have this week, and we know he drove 270 miles. And we have, oh, sorry, that's last week, silly me. This week, he drove b miles. We don't know how many miles he drove, but we're putting b in here to take its place. So we want to know how many total miles he drove. Well, I would add the 2 weeks together. So I would just say 270 plus b, because that's last week plus this week. And that's simply what they did here. So that's all we're going to do. We're just going to break it down a little bit and write an expression. The difference between expression and equation is that expressions don't have an equal sign. So it's only one side of an equation, basically. So we have Greg had M dollars to begin with. He just spent $32. Using M, write an expression for the number of dollars he has left. So if he started with M, this is how much money I have right now, or how much money Greg has right now. And then he walks in the store and he spends $32. Would we add or subtract that? Spent means we would subtract it. So that is simply all we're going to write. However much money he has, we're going to take away what he just spent. So that's it. M minus 32. Check. All right. To the next one here. Okay, so this one says Alan has K decks of cards. Each deck of cards has 52 cards in it. Sorry, each deck has 52 cards in it. Using K, write an expression for the total number of cards Alan has. So if he has K decks, we don't know how many that is, but each one of those, so let's say he had one deck. Well, that means he has 52 cards, right? Because each one has 52. If he has 2 decks, then we have 52 plus 52 because we have 2 decks. If he has 3, then we have 52 plus 52 plus 52. So we can see there's a pattern here. Each time I add a deck, I add a 52 to my list. So I started with 1 deck, I have 1 52. 2 decks, I have 2 52s. 3 decks, I have 3 52s. So this K is actually the number of decks here. 1, 2, 3, 4. I can change it depending on how many he has. But the 52 doesn't change. We'll have 52 for every single deck. So the way we write this is 52, and then each deck has 52. So the other thing is I heard the word each. That tells me right away I'm going to have multiplication. So we have 52 times K, or just 52K. And remember, I can change this and plug it in. So I was using repeated addition, but I could also use multiplication. So I just say 2 times 52. That would be the same thing as 52 plus 52. Or 3 times 52. Again, the same thing as 52 plus 52 plus 52. Multiplication is just repeated addition. That's really all it is. So we're going to type in 52. Okay. Check. All right, we're good to go. Next, and hopefully our last one here. So yesterday, Rihanna had C baseball cards. Today she got 8 more. So this one's pretty straightforward. She has C baseball cards, so we know she has that many baseball cards. And then today she got 8 more. So if I got more, then I know that I'm going to use addition because I want to add those 8 more that I just got. And that's it. We have C plus 8. That's how many baseball cards she has right now. Now, we'd have to know how many she started with to know the actual answer, but they're not asking us to go that far yet. So we click check, and we got that one. Yay, we're all done.